Hello and welcome fellow coders. Thank you so much for joining me today on my next part of my golang tutorial series. In today's video we are going to learn something very important, and that is how to control the flow of your code. I'm going to explain it to you by using a very simple example, and that is a calculate function. Despite its simplicity, it's packed with information, so make sure to fully understand it because you will use it all the time. So without further ado, let's hop into the IDE. Let's start by having a quick look at these functions right here. First off, we have a very simple add function followed by a subtract function. Next we have the multiply function and a divide function as well. But the divide function is actually not properly implemented. In cases we would pass 0 as an argument for number 2, the code would panic since we would divide by 0. But we can prevent that by using if statements. An if statement starts by the keyword if followed by a boolean expression. In our case we need to check if the value of number 2 is 0. Next we need to define what happens if the boolean expression is true. And to do that, we are going to open up a new code block like this. So everything within these curly brackets only gets executed if the boolean expression is true. In our example, we could for instance simply return 0, but the problem now is that the one calling the divide function wouldn't know that he passed an invalid argument. So the better way is to also return error with a descriptive error message. This way the one calling the divide function would get a chance to check if the division went through, or if an error happened. So we also need to add an error as a return type, and we also need to change the return statement right here. Since at this point there shouldn't be any errors, we can return nil. If the caller of the divide function now checks for the error, this will tell him that no error has occurred. Now that we have these functions in place, let's go ahead and write a calculate function that will execute one of these depending on the function argument. Let's go ahead and call it operator. And we also need two floating point numbers to pass to the function we want to calculate. As for the return values of this function, we need a float 64 for the result and an error in case something goes south. Okay, cool. So what this function is basically going to do is, it will check the value of operator and execute the respective function. So for instance, if operator holds the value plus, it will execute the add function. So the first thing we need to do is to check the value of operator, and we again are going to do this by using the if statement. Let's go ahead and take the example from before and check if operator holds the value of plus. If that's the case, we can call the add function and pass in number 1 and 2 as arguments. And we will also directly return the result of the function as our first return value, and nil as the value of error, since there is none. For our calculate function to compile, we also need to return some values in case the operator does not hold the value of plus. So let's go ahead and return 0 as the result, and we should also return an error. That is because this line should only be executed in case an invalid operator has been passed. So we should also make sure that the error message is as expressive as possible. Now that the calculate function is finished, at least for the plus operator, let's go ahead and use the main function to check if it's working correctly. So first, let's create some variables that hold values that we will use as arguments. Next we can call the calculate function and store the return values in their own variables. The first thing that you should always do in case a function returns an error is to check if the error is not nil and act accordingly. Make sure to remember these 3 lines, you will use them basically every 5 minutes. This is the golang way of dealing with errors. Basically every time you see a function returning an error, you should definitely make sure to check if it's not nil. In our case, I will simply go ahead and print out the error message. This should be enough for our example. And lastly, I'm going to print out the result that our calculate function returns. The only thing that's left to do is to fire up the terminal and run the main file to see if the calculate function actually returns 12, which it does. Great. Okay, the next step obviously is to incorporate all the remaining functions into the calculate function. But before we do that, let me quickly define the 2 default return values right here. You will see why I'm doing this in a minute. Okay, now we can return the result and error variables. The next step is to change the if body. Instead of directly returning the values, we will now set the result and error variables. Now it's easy to understand why I put the variables on top. First we set the default values, then we are going to check for the operator value, and if the if statement is true, the values of the variables will be overwritten. Okie dokie, now we can go ahead and add the remaining cases. For simplicity's sake, I'm simply copy pasting the if statement and changing the functions according to the operator, so nothing fancy. The only thing worth mentioning is the divide function. Since it already returns an error, we can immediately set both variables in one line. Okay, that is it for the calculate function. Now let's go ahead and see if it's still working. Since we didn't change anything, the result should still be 12. Awesome. Okay, now let's go ahead and change some values. Let's for instance divide both values. Okay, let's run our main again and okay, we have the correct result of 5. Now let's go ahead and change number 2 to 0. This should return an error. Okay, cool, the error gets printed out. Awesome. So our calculate function seems to work fine. But there are still things that we can improve. Let's have a look at the calculate function again. If we pass in plus for the operator, the first if statement gets executed and the values get set. But all the other if statements still get checked before we return the results. This is unnecessary because we already know that the value of operator is plus, so this can be improved. And I'm going to show you how. Instead of using multiple if statements that get checked sequentially, we are going to combine these by using the else if operator. Even though this does not look very different, it has one huge advantage. Again, if we pass in plus as the operator, the first check is true and this part gets executed. But instead of checking all the other cases, the else if operator recognizes if one check was true and then skips all checks below. So in our case, all these checks do not get executed because the first check already resulted in true. And same as before, result and error get returned. So whenever you have multiple checks but only one can be true, it's highly advised to use the else if operator. When using else if, it is a best practice to also use the else statement. The else statement must be the last one and acts as the default case. This is usually the place where you would return an error, because none of the checks has been executed. In our case, the else statement is the place where we set the default values for result and error. And for that to work, we also need to change the first two lines of our function. Okay, great. Now let's see if our code is still running. This seems to be the case, because it's still returning an error. Now let's try a different case. Okay, cool, still working. Now let's go ahead and put in some invalid argument for the operator and see if the default case is working. Which is the case, nice. So as you can see, all these checks did not result in true, and that is where the else case kicks in. Now I'm showing you guys a different way of how you can control your flow in your code. It is completely interchangeable with the if-else block, so you can use whichever you like best. But this wouldn't be a complete tutorial if I wouldn't show you how the switch statement works. You start off by writing down the switch keyword, followed by whatever you want to check. In our case, it's the value of the operator. This starts off the switch statement. Now you can define multiple cases that the value of operator can hold. For us, these are the exact same 4 values we checked previously. Now we can go ahead and copy whatever should be executed for each case. For the first 4 checks, this is pretty straightforward. But what about the else case? Lucky for us, the switch statement also provides a way to define a default case. And that is by using the default keyword. Simple, right? Now we can go ahead and copy the code from our else case and put it into the default case. Congratulations, we have replaced the if-else block with the switch statement. And as I said earlier, these are completely interchangeable and you can use whichever you prefer. To prove that that is true, let's go ahead and execute the code, and you can see that for multiple cases, the switch statement also results in the same output as the if-else block. Now it's time to show you the last thing about how you can control the flow of your code. And to do so, I need 2 print statements at the beginning of the calculate function. Don't worry about the text of the second one, this will make sense in a minute. If we run our code, we can see that both print statements get printed out in the same order we executed them. So absolutely no surprise here. Now let's cut out the second print line, put it in front of the first one and use the default keyword in front of it. Let's run our code and see what happens. Okay, now that is interesting. You can see that the console output is in correct order, even though the print statements are not. And to no surprise, this is because of the defer keyword. But how exactly does it work? Defer can be used in front of any kind of function, and it will ensure that this function gets executed at the end of the surrounding function the defer statement has been defined in. In our case, the defer statement has been defined within the calculate function, and whenever the calculate function has been finished executing, the defer keyword kicks in and executes the function that is following it. But what do you think will happen if we add a second deferred function? If you run the code, you can see that the print statements are in correct order, whereas the console output is in reverse order. So if you have more than one defer statement in your functions, make sure that you keep in mind that their execution order is reversed. So now that we have talked about what deferred functions are and how you can use them, we haven't actually talked about what their use case is. And to explain that, I'm going to switch to a different example. First off, you can see that I've defined 4 very simple functions. All of them simply print out what they are actually doing, and 3 of them return nil as their error return type. You will see in a second why only 3 of them return an error. But first, let's go ahead and call the openFile function and then do what we have learned before and check if the error is not nil. If that's the case, I'm simply going to print out the error message. Now we have come to a point where we don't want our code to execute any further. That is because we ran into an error, so our main function should quit. And we can achieve that by simply returning. Since the main function does not have any return types, the simple return keyword gets the job done. But if a function would return maybe an error or so, we would need to return nil or 0 if the function would return a float. I think you get the point. So if you want to get out of a function early, you can basically return at any given point you want. Okay, now let's go ahead and continue with our main. The next function I'm going to call is the readData function. And obviously, I'm also going to check if the error is not nil, print out the error message, and call return to stop the function from going any further. The last function I'm going to call is the writeData function, and same as before, if the error is not nil, print in return. And to see if the main function actually ran through, let's go ahead and print out no errors. If we run the code, you can see that we are opening the file, reading the file, writing the file, and no errors have happened. That is exactly what we expected. But if you might remember from before, there is actually one function left, and that is the close file function. Once a file has been opened, it should always be closed, so the close file function should be executed anytime an error has occurred. And of course, if no errors occurred as well. Now let's go ahead and fake an error and see what happens if we execute the code. We would expect that the error message gets printed out, the file gets closed, and we don't see the no errors message. That is exactly what the console output shows us. If we scroll up a bit, you can see that the close file function gets executed every single time. This is a perfect example of where we can make use of defer. By deferring the close file function, we can make sure that the file gets closed no matter if the main function ran through or if an error occurred. And we don't even need to bother where the error occurred exactly. So whenever you have functions that need to be executed no matter what, you can always use defer. Running the code obviously shows us the same output as before. Now the only thing that's left to do is to check what happens if no error gets returned. Running the code shows us that indeed no errors gets printed out, and of course the file gets closed too. It's worth mentioning though that the deferred close file function gets executed after the last print line statement, which was the no errors print line and actually the last statement in the main function. So keep in mind that the deferred functions get executed after the function has been finished. And that is how you control the flow of your Golang code. If you want to see more tutorial videos, please let me know in the comments down below, subscribe to the channel if you're new, and of course hit the like button. And until next time, keep on coding!